screen?
No audio.
You can't hear me? It's bouncing on my side. So Catherine, can you hear me?
I can hear you now.
Oh, okay, perfect. Okay. So let me just jump into the Slack questions that we had already. Okay, so first question that we had was, can we do encryption on the front end, right? So we built a pretty good auth system. We have that all up and running, but we're sending the password and we can see that happening in the network, right? So let's open up our VS Code and start sharing our screen here. I'm actually going to quickly change my screen resolution before I do that so you guys don't have to squint. Okay, and we'll share, and we're going to share desktop 1. Just throw my Slack over here. And Zoom's doing that weird thing again. Where the box is in the wrong spot. You know, Zoom normally likes me, but tonight it is just out to get me. Oh, come on. Can you guys see my whole screen, or does it cut off at terminal kind of right here?
I can see your whole, it's not cutting off at the terminal.
Yeah.
Okay.
The whole screen.
Okay. Then we will just carry on, even though there is a the green line, the screen sharing line looks like it's cutting off like right here, but as long as it's working, that's what really matters. Okay, so first thing I'm going to do is I'm going to CD into my back end, and I am going to, oops, I am going to npm start my back end, and I get an error because, of course, I forgot to turn on my Postgres server. So I'm going to open up my Postgres app, and I'm going to hit start. And then I will stop my backend server and start it back up. And we have that up and running. And we are going to open up another terminal, and we are going to CD to our front end. And we are going to npm start that, and that should open up our front end code. And okay, everything's set there. So before I dive into this, I'm going to open up pSQL, and I'm going to connect in and look at my users table. And we have a whole bunch of user accounts in here that I don't necessarily remember the passwords to. So I'm just going to go in here and clear out this this stuff in the database. It's super important to have a local development environment, and this is true if you're taking on more client work as well. Is the client might just give you access to their production server. You definitely want to have that kind of up and running on your local computer instead of working on their live website and accidentally deleting one line of code that kind of crashes everything. So having a development environment is super important. So I'm going to go here, and I am going to confirm that I know what this username and password is. So I'm going to sign in with CIC123. I'm going to hit login, and then when I hit am I logged in, this 3 here shows up. Which means it's adding the 2 numbers and I am signed in. And I can confirm that by hitting log out and then hitting am I logged in, and that goes away. Okay, so what's happening here? If I go to my network tab and I hit login again, I can pop open this request. And in the Sorry, I'm just responding to someone. On Slack. Okay. So if we, let me just grab the link for this so people can jump in. Artifact is in. Okay. All right, so back to our login request. So we're going to look here and we have our password sent in plain text over 123. Now, if we're serving this website over HTTPS, anything that we send in the body of a request is naturally going to be encrypted. Because we loaded the page over HTTPS, our SSL certificate that's serving the page is going to naturally encrypt the information. However, it's always a good idea to add more encryption if you can when it comes to secure data. So what we're going to do is in our backend, we're going to go down to our login code. And we're going to come down here and we're going to see what's happening here. And what's happening is bcrypt.compare is taking that raw password that gets uploaded and it's comparing it to the user DB password. So it would be much easier if we weren't using bcrypt to switch over the encryption to the front end. And the reasoning behind that is bcrypt, the compare methodology, is taking the raw hash from the database and comparing that to the password that got uploaded. So if we just took this bcrypt.compare function and put it on the front end, we would also have to send back the hash to the end user to compare the two together. And that's just a bad idea. So, and it's a bad idea because we don't want to send the hash to a user, right? We don't want to say, hey, I'm user 123 and I think my password is ABC. And we don't want to go to them and say, okay, well, we have this hash password of that's the correct information, because in theory, they could break the hash. So what we're going to do is we're going to go to bcrypt and we're going to look up their documentation. And what we are going to find is bcrypt to hash a password. We use bcrypt gen salt, or we can do technique 2, which is going to hash the password with my plain text, the number of salt rounds. So what we're going to do, let me just confirm we can do this first. Take a quick look in our database to see. I'm going to do a quick Google for this. Bcrypt hash on front end and see what comes up. Yeah, I don't know if it's possible to encrypt on the front end with bcrypt because it's a little too secure. We would have to send the salt information, and because bcrypt is doing it with 10 different rounds, I know that's not making a ton of sense. We might need to do this. Let's see. All right, let's give this technique a try. So what we're going to do is we are going to okay, we're going to give this a try. So we're going to use this library called crypto.js. The reason why we can't use bcrypt and just copy this code, yeah, we're going to run into some salt issues if we try and use bcrypt on the front end to encrypt. So basically what's happening here is we need to we need to encrypt the password on the front end, but if we use a hash, we're not going to be able to decrypt it when it gets to the back end. The special thing about hashing is that it only works one way, right? So we can put in an input, and it is going to generate the same hash every time, but we're going to run into a problem when we hash that information on the front end, send it up to the back end, and the back end is going to get that hash and be like, what do I do with it now? I can't turn it back into a plain text password. So what we're going to do is in our in our front end terminal, excuse me, we are going to npm install -- save crypto-js. And we are going to, while that installs, we are going to import crypto.js from crypto-js. Now, when we call our login function, instead of sending up our password in plain text, we are going to say crypto.js.aes. And AES is a kind of encryption algorithm. And we are going to encrypt our password. And the password is going to be the password that we typed in from this.state. And we're going to encrypt it with a password super secret encryption key. So we're going to do that on the front end. All right. So let's test to see if this is going to work first. So we are going to go to Chrome and we are going to open back up our code. I'm going to clear the network request that already happened, and I'm going to hit login. And our login 200 happens, and we're going to scroll down here and it sent my password as 123. Okay, so that encryption definitely isn't working. Why isn't it working? Well, I forgot to fire back up my server, my React server. So I'll do that. It will refresh. I'm going to do CIC. I'm going to do my password as 123. I'm going to hit login. And we get a whole bunch of errors. Okay, converting circular structure to JSON. What it is saying is that it choked doing this. So I'm just going to copy that code out and make that an empty string. And I'm going to console.log what's happening when we crypto.js AES encrypt. So let's go back here. Let's type in our username, our password again, hit login and go to our console. And this is what comes out, is this crazy object with the super, the algorithm, the ciphertext, the init, all of this crazy stuff. So what we actually want is all of that as a string, right? We want to just upload what it outputs essentially. So I'm going to do CIC and 123. I'm going to clear that. I'm going to hit login. And now we get some cipher out. We get something that's encrypted. Okay, great. So let's take that code. Let's put it back in our password. I'm going to CIC 123. I'll log out first, and then I'm going to log in. So we can't sign in, and that's what we want to happen because we're now passing the password up in some encrypted format, and it can't read that. So the server's getting the encrypted information, and it's like, what is this? This definitely does not match what's in the database. So what we're going to do is go back to our backend code. We're going to go to our backend terminal, and we are going to npm install -- save, and we are going to install crypto.js as well on the backend. So let's go ahead and pull that in. We're going to say const crypto.js equals require crypto-js. We are going to fire up our server again with npm start. And then in our login function, before we compare the rec.body.password, which is getting uploaded, it's still uploaded in an encrypted format there. So what I'm going to do is I am going to say const bytes, because the way the crypto algorithm is going to decrypt it is going to put it out in a byte format, which isn't helpful to us, but is a step in the right direction. And what we are going to do is we are going to say crypto.js.aes. We need to tell it what format, what encryption algorithm we use. And we are going to decrypt our rec.body.password. And we are going to tell it, hey, the way you decrypt it is using the same key, the same password we use to encrypt it in the front end. Okay. And then here, we are going to say, all right, now that we have the bytes, we need it in plain text. We need to convert those bytes into a string that we can read. So what we're going to say is const decrypted password equals bytes dot to string, and then we are going to use crypto.js again and say, hey, the encoding that we want it back in is UTF-8, and UTF-8 is the most common way to encode a string outside of maybe ASCII. But basically what we're doing is we're passing in the password, we're passing in the encryption key that we use on the front end. And where is that? This is here, right? So we're saying, hey, crypto.js on the front end, use AES to encrypt something. This is the thing we want to encrypt, and this is the key that we're going to use to encrypt it. Then when you get that data out, give it to give it to us as a string. Then we're going to jump to our backend code. Our backend code, again, we're going to use crypto.js. We're going to tell it that it's AES that we're using, and we're going to decrypt. Okay, what are we going to decrypt? We're going to decrypt the password sent to us in the encrypted format. And now we're going to use this key to unlock what the password is. Then we are going to take that data that comes out in byte format and convert it into a string that we can use. And then we are going to compare the decrypted password to the user database password. I will be shocked if this works on the first try. Let's give it a shot. So I'm going to refresh here. I'm going to log out just in case we're logged in, and I'm going to CIC with 1, 2, 3. I'm going to log in, and then I'm going to hit am I logged in, and by some miracle 3 came out. Okay, it's great, it's working, but you know what? I don't feel comfortable with this code. Even though it's working, I want to know how it's working. So what I'm going to do is I'm going to go back to my backend, and I'm going to do 3 console.logs. I want to see the console.log of the password the front end uploaded. I want to see a console.log of the bytes that came out of the decrypt function. And I want to console.log the decrypted password. Okay, I'm going to save. I'm going to go back. I'm going to hit login. And what I see down here is that the user is already signed in with a cookie. So because we have our cookie authentication happening, it's not rerunning this code. So I'm just going to hit log out, and then I'm going to log back in. Now it's running with the password information, and I'm going to go here. Okay, so what console logged out? The first thing that we had was ref.body.password. Here's what it uploaded. Is that weird string. So great. And if we look in our network tab, we can confirm that when we look at login, what got uploaded was this huge encryption, this huge encrypted password. Okay, now what happened? We told crypto.js to decrypt that information with the same key that was on the front end. Okay, and that came out as this crazy words array with a sig bytes 3. Okay, that's just the computer decrypting that information in a method and a storage method that makes sense to it. But we want to tell it, hey, we need that back as a string. We need to know what that decrypted password was. And so we decrypt it, we take the decrypted bytes, we pass in the format. This UTF-8 is basically saying, I want it back as a string. I want to be able to know what they typed in. And then we're going to use that decrypted password and dump it out into the log. And sure enough, 1, 2, 3 comes out. Now I have some other console.logs here and here, which are these final 2 lines. But what matters here is that we get to see the decrypted password. And that's what 1, 2, 3 is coming out here. So one final point I will make on this is if I go to my app.js and change my super secret encryption key to super secret encryption key 1 and save, then go back here, log out, and try and log back in, it's pending in my network tab. But if we go to the server, we're going to see all of these errors here. And it says unhandled promise rejection error, malformed UTF-8 data. So what's happening is it's trying to decrypt the password and it's failing. Okay, why is it failing? Because the backend is trying to decrypt it with the key, super secret encryption key, but the front end is encrypting it with the super secret encryption key 1. So what's happening is the key that we use to lock the lock and the key that we use to lock the encryption is not matching the key we're using to unlock the decryption. So what's happening is it's failing and it's going, I can't get that password. So whatever you encrypt with on the front end also needs to match what you encrypt with on the back end. So I'm just going to clean this up. I'm going to take out my console.logs, and I'm going to make sure my super secret encryption key is matching on the front end. I'm going to go back to this code, and I want to take out these console logs as well. And just clean that up to say with password. I'm going to hop back here. I'm going to log out. I'm going to log in with CIC in 1, 2, 3. I'm going to check to see if I'm logged in. That came out, so I am. And it's important not to just check to make sure that you can log in. It's important to make sure that it won't let you log in if you type in the wrong password. So I'm going to add something there. I'm going to hit login. I can't sign in. And if I hit am I logged in, I don't get the response there. Great. So we encrypted everything on the front end. And again, if we go to that network tab and look at our login, we see that it's uploading the password in some encrypted format, and that's what we want. So now we are not only encrypting on the front end by using AES, we are also hopefully uploading that information to the server over an HTTPS connection, which will add another layer of protection automatically for you. I'm going to stop there. Does anyone have questions on that front end encryption before I keep going?
I posted one,
Mm-hmm.
a link in Slack. I don't know if we're talking about apples and oranges. But the first link, JavaScript cryptography, it says it's doom. Is this really when you want to be super, super, super secret? The first link way up above, if you click on it, it gives details on this particular doom they're talking about. But are we not talking about a, here you go. I can happily ignore it if it's not relevant.
So what they're saying is you could use SSL TLS to solve the problem, but that's expensive and complicated. My guess is that's a little dated, or just no longer true. Yes, this was published back in 2011.
Oh, wow. Gosh, I should look.
And so why they're saying that is expensive and complicated is not just 8 years ago was that expensive or complicated. That was expensive and complicated 3 years ago. And the major thing that changed that is all these browsers like Chrome and Firefox started looking at security and started thinking, hey, does security matter? And they realized that how insecure websites were that weren't using HTTPS. So they were like, man, we really need to start encouraging HTTPS use. And the web developers that made websites went, yeah, we're fine with that, but it's hard to set up HTTPS. So Google and Firefox and a couple other companies fought back and said, you're right, SSL is expensive and you need an SSL certificate in order to serve a website over HTTPS. So we are going to make a free way for you to get SSL certificates. And the project that they did that with is one called let'sencrypt.com and .org, I'm sorry. And if you look here at the major sponsors and donors, you will see things like Mozilla and Google Chrome and Cisco, which is the biggest router manufacturer, and Facebook, and a bunch of other companies here that went, yeah, you know what, this is important. We should have a way to get SSL certificates for free.
Right.
And so they made this project, and this project was great. and came out, I want to say 3 or 4 years ago. But when I tried to use this, it was still really complicated 3 or 4 years ago. And the reason it was complicated was because they hadn't integrated with the servers. So it was great that you could get an SSL certificate, but it was still hard to set it up even once you had that free SSL cert. So Let's Encrypt started working with the server software, and Automatic is the company that makes WordPress. And so WordPress got on board with this, and then a bunch of web hosts got on board with this. So you see DigitalOcean down here. GitHub uses it for securing all of their websites. There are a bunch of different companies that got on board and said, we will make it easy for you to not only get a certificate from Let's Encrypt, but install it and set up your site to serve over HTTPS. And as soon as SSL certificates became free, it became much more popular to use them.
Okay. Now the Stack Exchange, it was a year ago, and I think the person was kind of debunking or adding why it's not as, he's stating facts that it looks like he's like, yes, this, but what do I want to encrypt in client side?
So
another time. That's all I needed to clarify. That is old.
Yeah, so there are definitely more secure ways of doing it. There is something called JWT, which is used with Firebase. They are Java Web Tokens. Let me confirm that before I, JSON Web Tokens. And JSON Web Tokens are essentially an even more secure cookie. Basically, the issue that we have here is that when we encrypt on the front end, anyone who's running this front end code in our app.js or app.js can see that we're encrypting the data with the super secret encryption key and could just use that key to decrypt the information as well. So let's say that, you know, I'm an evil landlord and I provide Wi-Fi to all of my residents, but I'm stealing information, right? I'm trying to crack their passwords. Well, my super secure React app is encrypting the password on the front end and hitting login. So all the evil landlord sees is this super long password. But if that evil landlord wanted to, they could go to the website that I entered the information in, snoop around in the source code, and find out that the way that that is encrypted is with super secret encryption key and decrypt that information.
Easily.
Just they would be able to use the same line of code we used on the back end. With that said, if the super evil landlord is having, you know, hundreds or thousands of passwords getting sent over their network, they're going to be set up to read password and go, okay, is this password being sent in plain text?
Okay.
So let me just summarize all of this because I think we're going a little bit down a rabbit hole. The answer to should you encrypt on the front end is yes, you should use HTTPS. You should be serving your website over HTTPS, and you should be using an SSL certificate to do that. If you do that, even if you think you're transmitting your password over plain text, as long as you are making an HTTPS request to your backend, that password information will be encrypted.
Okay. Got it.
The longer answer is, you know, every step you take for security, is at least one step further. And a lot of people are going to see that this is encrypted. They're going to know that a password that long isn't your actual password, and they're going to move on to another site that probably isn't using HTTPS at all. So we can encrypt it. It is not the most secure thing, but it is yet another layer of security we can use. The most important thing, though, is that you are encrypting and hashing your passwords in your backend, because all of these breaches that we are hearing about are not hackers who are intercepting data as it's being transmitted. It is hackers who are getting access to the database or getting access to the logs where all of this important information is stored, and seeing that once they get access to it, it is not stored, hashed, or encrypted, or in a secure format. So
is it not necessarily because the hackers are very good, it's because the people aren't protecting their data as well as they should? Okay. It's not that they're genius hackers, it's their stupid corporations.
Yeah, it's the fact that, data, there is a saying that data at rest, so data when it's being stored, data when it's not being transmitted, should be stored encrypted, right? So when that information is sitting in our database, as of right now, there is no way to take this super long hash, dump it into a program, and have my password come out.
Cool.
Because we salted it, and because we use a secure algorithm like bcrypt, that information cannot be turned back into my password. The only way to get that information back out is to compare the password that I upload into this hash, and if the two hashes match, we know it's the right password.
Cool.
So definitely more secure to encrypt your data in the database than it is to necessarily encrypt it in the front end. What we did and what us using AES is another layer of security. It can be cracked. It is not super secure, but the TLDR of all of this, the summary of all of this, is the best encryption for your front end when you transmit any information, not just the password, to the back end, is to use HTTPS.
Cool.
Okay, that was really long. I'm sorry if that was a twisty road to get to that. The other question was about authorization. Let me just scroll through here and make sure. Okay, so Caitlin had a quick question that I will answer just because it's not directly code related. Caitlin asked, how do we store things like addresses and phone numbers? Addresses and phone numbers typically are not stored encrypted in the database. They are something that you need to use without having the user upload it every time, right? So we can't hash the address information, and we can't hash it because if a user types in their address, right? Let's say we're building an e-commerce website, and the user creates a new account and types in their shipping address information. When they go to check out, they want their address information to automatically fill in. Well, if the information was stored in a hash in the database, there's no way to pull that data back out and show it to the user. The only way to see if the address was matched what they said was for them to type in their address all over again. So things like addresses and phone numbers typically are not stored in an encrypted format. You could, in theory, encrypt them when you put the information in, and then use that same key to decrypt them when the information came out. And that process would be very similar to what we did here. On the front end, we use crypto AES encrypt, and we use some key. What would get stored in the database would look like something random, but when we pulled it back out of the database, we would use this decrypt function with the same key and would be able to get that address information out. So that's another layer of security, because if your database is compromised and all the data gets stolen out of it, but your backend code does not, they have all of this encrypted information, but because they don't have the key, it just stays as encrypted information. So you can encrypt things as they go into the database and decrypt them as they go out, but you don't need to go crazy on that. So things like passwords are super important. For the most part, things in the database are just stored in plain text. So phone numbers get stored as a string, and then addresses, the only kind of weird thing that you store with addresses is you need to figure out what format you're going to store them in. So you don't want to store that as one field in the database. You don't want to just store address, because you have address line 1, right? Your house number and your street name. Then you have address line 2 as well, which would be apartment 1. Then you have city, state, and zip, and those are all 3 separate fields. And that's pretty common, right? When you're checking out on a website, those come in separately. And it's a good idea to store it that way, because when you need that address information later, you might just need the zip code that it's going to, and you don't want to have to figure out, okay, out of this long string of their entire address, what's their zip code? And you can't just go, oh, it's the thing with numbers, because their house number is in there. And you can't go, okay, well, it's the thing with 5 numbers, because what if their house number is 5 numbers long? So it's a good idea to store them in separate fields, but I have not seen a database that stores that in an encrypted format. The most common times you see things encrypted are passwords and hashes that are one way. And then the other thing that you see encrypted is things like social security numbers. But when they store social security number, that tends to be stored encrypted using an algorithm like AES, where they can take a key and unlock it without the user having to prove that they know that information, which is, again, how passwords work. For addresses and phone numbers as well, you wouldn't put that information in a cookie. You would query the database. So what you tend to do is store just the user ID in the cookie. And then whenever you need to retrieve information about the user, you can pull that user ID out of the cookie and then use the user ID to query the database to get whatever information you want. And the reasoning behind that is, let's say you're making an e-commerce website, right? So the user signs up, they sign up, they type in their username, their password, and their address information, and they sign up on their phone. Okay, well, they're now logged in on their phone. Their phone has a cookie that identifies them as user ID 1. Now they go on their computer and they realize they're not signed in, so they hit login, they sign in with the same username and password, and user ID 1 shows up in their cookie, and you're good to go. Okay, well, what happens now when the user changes their address on their phone? Well, if you go to check out and that information is stored on the cookie's not going to update on the desktop computer because they updated their address on their phone. So it's generally considered a better idea to just store user ID in your cookie information and then keep the rest of the data in the database. And whenever you need it, you can query the database with the user ID that's in the cookie to figure out the rest of the user information. I'm going to pause again for any comments or questions. I'm monitoring Slack, by the way. So if you want to ask the questions in Slack, that's fine. If you want to ask them in Zoom, that's also fine.
So instead of storing like their information in a cookie, like what Caitlin was saying, so you would just like when they log in and you retrieve like their user ID, could you just pull in, would just pull in all that other information along with that user ID?
Correct.
Okay.
So basically what we would do is like we would go to our front end here, and let's say that zip code is part of creating a user account, right? So I'm just going to copy this quickly, and I'm going to say zip code, and I'll change this to zip code and zip code and zip code and zip code and zip. That stays the same. Okay, so and then when we create our account, we need to also upload zip code as this.state.zip code. And let's just take a quick look on our front end. Okay, that did what I wanted, and zip code is typing in as a password field, so we probably don't want that. So we'll just change this to text. And then in our back end, we're going to go to our create account endpoint. And when we create the user, we are also going to store their zip code as rec.body.zip code. But because we're storing that in the database, we have to go to our models and update our models to also store a zip code, which is going to be a sequelize.string. That's 5 digits long. Now you might say, string, why am I storing that as a string? Zip codes are numbers. Well, that's a trap that I have personally fallen into before. Zip codes are 5 digits, but they can start with a 0. I grew up in New Jersey and my zip code was 08226. Well, what happens when we store 08226 in the database as a number? It goes, numbers don't start with 0. Your zip code is 8226. Okay, well, that doesn't work. I don't want to drop my number, the 0 as my first number. So that's why you would normally store a zip code in the database as a string. Okay, I'm going to add one thing onto this, and I'm just going to say force true. And what that's going to do is it's going to empty out my database the next time the server restarts. Oops, sorry. And is going to set up the tables from scratch with that new table column. So I'm going to look in my console. I'm going to stop it and start it. I'm going to go to my pSQL and I'm going to refresh my tables and open up users. And now I see my zip code field is here. Okay, but my content is empty. So before I forget, I'm going to remove that force true so my database doesn't empty every time the server restarts. I'm going to refresh. I'm going to create my username and password just like always, and I'll create my zip code. So I'm going to hit create account. I'm going to look in the network tab, and it did upload my zip code. So I am going to go to my database and refresh, and now my zip code is here. Okay, so let's say that when I hit am I logged in, I want it to show my zip code. So the first thing I'm going to do is I'm going to sign in, and I'm going to hit am I logged in, and we see 3 came back. Okay, now I want that to return my zip code. So I'm going to go to my index.js. Well, first of all, I'm going to look at my isLoggedIn function. And my isLoggedIn function is called login checker. And what login checker is doing is it's saying, hey, if rec.cookies.id exists, go to the next thing. So what I can do here is I'm going to make this an asynchronous call. And what I'm going to do is I'm going to say, hey, we already confirmed that the user is signed in because it passed login checker. So if they weren't signed in, it would have sent back 401, no cookies for you. But because they are signed in, it should go next and it should let me run some code. So what I'm going to do is say const user db equals await models.user.find by PK. Oops. PK stands for primary key, and our primary key in this case is our user ID. Okay, well, what is our user ID? Our user ID is stored in rec.cookies.user ID. And what we are going to do is our result is going to be userdb.zipcode. So what we're doing is, hey, when you hit this endpoint, which we still have called add, make sure they're logged in. If they're not logged in, this endpoint's going to, this middleware is going to run and send back, hey, there's no cookie that exists, so you must not be logged in. If they are logged in, go ahead and continue running the code. Okay, so this is going to run here. And before we send any information back to the end user, we are going to go to the database and we're going to go to the models and look at the user table. And we're going to find by PK. So find the ID where the rec.cookies.user ID is. And that information is going to come back in user DB, and we can use the zip code information there. Again, this is going to be a miracle if it works on the first time. I'm going to hit am I logged in, and sure enough, our zip code shows up. So in theory, I could, when we log in the user, here, log in, and we create the cookie that we send back. We could create another cookie here that said zip code and store the zip code as rec.body.zipcode. But again, that's not considered best practice because they could have cookies on multiple devices. And if they change their zip code in one place, they might not have logged in on another device and have that updated information. So we only store user ID in the cookie. And then when we need that information back out, we use the user ID in the cookie to go to the database to get the information, and then we return that back out. Any questions? Sorry, I know my keyboard is probably pretty loud, but I'm just monitoring the Slack. The next thing that I'm probably going to tackle is authorization. But I want to make sure that no one else has other questions before I start diving into that. Authorization is probably going to take me at least 30 minutes to get it set up. So I want to answer any other questions people may have before I dive into that one.
Yeah, I think all my questions are authorization, so I think I'm all set for now.
Okay. So I don't think I can delay on this any further. I think I finally need to do authorization. Okay. So
I have a question
Sure.
before you move on. I was wondering if you could go over communication between the React files, just like on how to pass data from one component to another if they're in two separate files?
So you're saying that if we have a parent component that has two child components, how do we pass data from one child component to another?
Or just like if you had a login, separate login form and a sign up form, and you wanted the two to communicate, like pass the username to make sure the user is signed up. I don't know how much that makes sense.
Yeah, no, it definitely does. And it's a very common problem when you're getting started in React. I'm wondering if that is a better question for Joey. With that said, I can take a quick stab at it. I know the answer. I don't know how well I'm going to be able to explain the answer. But I can give it a try. So to make it as simple as possible, I'm going to take my zip code form field, and for some reason, I want to make that its own component. So what I'm going to do is I'm going to take that code out, and I'm going to put a new component in here that says zip code. And my zip code component, I need to now define what that is. So I'm going to say class zip code extends component. And that is going to have a render function in it. And that render function is going to return my form group. So what I did is I just took my code out for zip code. I use it right here. And then I created a new class, a new component for it down here. So let's see what happens. It crashes and it says cannot read property zip code of null. So what's happening is it's trying to read this.state.zip code, but because state is component specific, we never told it what the state of zip code is when it first starts. So we are going to say state equals zip code with an empty string. And when we come back in here, we have our create account. Great. So I'm going to type in a username and a password and username and a password and some zip code 123. And in my create account, I am going to just comment all of this out for now. And I'm going to console.log my username and my password and my zip code. So I'm going to hop back over here. I'm going to type in my username. I'm going to type in my password. I'm going to type in a zip code. And I'm going to hit create account and look in my console. And we have A as my username, which is what I typed in. B is my password, which is what I typed in. And undefined. Okay, well, that should have been my zip code. Why is that not my zip code? Well, we're saying this.state.zip code. Well, state is component specific. So it's looking in my app component for my password, but because, I'm sorry, for my zip code, but because zip code is now its own component, the parent component, which is app, no longer has access to this.state.zip code. And the reason for that is because components are designed to be reused. So what if I had 3 different zip code components on my app for some reason? Well, how is it going to know what this.state.zip code to reference? It might try to be the first component or the second component. So what we end up doing here is we start using props. And props are the way to pass information, objects, or functions from a parent component to a child component. right? And why I keep on saying parent and child is the parent component is the app in our case, and the child component is the zip code that shows up in the app. So what we're going to end up doing is we are going to pass in two pieces of information to our zip code function. We are going to pass in zip code, which is equal to this dot state dot zip code. And we are also going to pass in change zip code, which is going to equal a function that we're going to define in a second. Okay, so what we're going to do is instead of using the state in our zip code component, we instead are going to use this .props.zip code. So take whatever information is getting passed in from the parent component and pass it in to zip code. Now, before we test to see if this works, I'm going to scroll up here and I'm going to define the zip code when the app first starts as 1, 2, 3, 4, 5. Okay, and I'm going to refresh and 1, 2, 3, 4, 5 is not showing up. Okay, so I'm doing something wrong. So let's figure that out. I am going to look back here and the value should be this .props.zip code. So let me go back up to my zip code component, and zip code needs to pass in zip code with a capital C. Okay, now my 1, 2, 3, 4, 5 is showing up. Great, but when I go to change this, I'm typing in a bunch of different things and nothing is changing. Well, that's because the prop is passing the data in, but we're not giving it an opportunity to change the data. So what we end up doing here is we say, hey, change zip code is going to take an event. Oops, turn on caps lock. And what the event is going to do is this .set state zip code with a capital C to the event .target .value. And then when where's my code? When we change it in the child component, we are going to this .props.change zip code. So let's make sure that's working, and then I'll try and talk through it. So I'm going to refresh. I'm going to click on my zip code, and I'm going to change that information. Now for the ultimate test, I'm going to hit create account, and my data comes back out. And I can type in some information here and hit create account, and AB 12344 or 12340 comes out. Okay, so what's happening there? We're doing two things. We are sending in the value of zip code from the state of the parent component. That parent component is the app itself. Okay, and what are we also sending in? We're sending in another prop called change zip code that's going to run this code. But the important thing is it's going to run this code in the app component, the parent component. It's not going to run the code in the child component. So when we call this .set state, we are setting the state of the parent component instead of setting the state in the child component. So let's look at the child component. The child component has a zip code and it has a value, but instead of the value coming from the state of the zip code component, the zip code component is going to use the value as whatever prop gets passed in called zip code. Now this on change happens. Now we change a form field. Okay, well, how are we going to handle that? So what we're going to do is instead of handling the change in the child component, which is zip code, we're going to handle it in the parent component. So whenever there's an on change happen, hey, go run whatever change zip code got passed in. So we go back up to our props, and our props for zip code are some function that's going to run, and that function is going to set the state in the parent component, in the app component. So when we go to create our account, which all we're doing is console logging out the data, because we made all of the state happen in the app parent level, it now has access to this .state.zip code. Does that answer your question?
Yeah, let me see if I got this correct. You're doing all the changes in the parent component, and then you're passing that data to the child component, which is just updating whatever information it's receiving. It's basically
You got it.
Okay.
You hit the nail on the head. And Joey will go into that more in the next 2 weeks, because managing state not only in React, but any front end app, whether it's in Angular or Vue or React or even jQuery itself, state is becoming a very complex and very hard thing to manage. And so there are some techniques to doing that. And Joey has a lot of experience doing that. So he will go into that more in depth and how to figure out what component should have your state and how high up it needs to go and how to best manage that. But that is a very simplified way to manage it.
Okay.
So I'm actually going to delete that code just because it doesn't make sense to run, to have zip code be its own separate component. However, it will, of course, live on forever in the stream itself. So if you would like to take a look at it, you can. Just going to put it back here. We are going to just grab this and do zip code and zip code. And I'm going to delete out my 1, 2, 3, 4, 5. And I'm going to make sure that that works. Okay, great. Any other questions before I dive into authorization? Oh, Eva, the question that Anna had was what happens when you have a parent component app, and then there are some children components like zip code. And what happens there is when zip code changes its information, it changes its state. It's very hard for app to get access to the data when the data, the state, is in the child component. So what we end up solving is we end up storing the data in the parent component and then pass that data into the child component using props. And then we also pass in a function to that child component so it can update the information in the parent state. And the reason we have to do that is because props are one way, they are read only. So when you have a zip code that gets passed down in with a prop, you can't just say this.props.zip code equals my new information, because it doesn't update in the parent if you do that. So what you do is you send down the read-only zip code, which is just going to come in as a this.props.zip code, but then you also pass in a function, change zip code, that is going to update the parent state zip code and then pass that new zip code in via the prop. That's one that I think will help if there's a diagram for. So if I remember, I will draw out a quick diagram of how that works. any other questions before I dive into authorization? Which I really don't want to do, so if there are any other questions, feel free to throw them out now. And it's not that I don't want to do it because it's not important. It is definitely important. I don't want to do it because I just don't enjoy coding out authorization. Okay, I don't think I can delay any more on authorization. So the first thing we're going to do authorization is we are going to make another button. And our other button, you know what? This is going to make no sense, but this is what we're going to do. So we are going to make it so when we click "Am I logged in?" It's going to return zip code if we are an administrator, and it is going to return the sum of two numbers if we are not an administrator. That makes no sense, but it should cover the concepts of authorization. So what we could do is make it so there is a form field here that's a select where you get to pick what level of authorization it is. But normally you don't want the end user to be able to set the authorization levels. So what we are going to do is we're going to do that just at the database level. So we are going to create a new form field here that is called auth level, or you know what? Let's make it a little bit friendlier. Let's call it account type, and that is going to be a sequelize.enum. And enum we probably haven't covered yet, but it's essentially an array in the database. So it can only be one of the values that is listed here. So we are going to say you can either be an admin or a user. Okay, we're going to save that. We're going to turn our force back to true. And then we are going to remember to take our force true out once the database reboots. So I'm going to go back to my pSQL. I'm going to refresh. And in my users table, I now have an account type. Okay, but the content is empty. That's fine. So I'm going to go to my front end. I am going to go to my username and I'm going to create a username and make my password 123 and create some zip code and hit create account. And it says user created. And I'm going to take a look at my database. And we have our CIC, we have our password. Salt, we don't need anymore because we're storing in the bcrypt. So we should probably delete that column, but it's fine for now. Zip code stored and account type is null. So I'm just going to double click this and I am going to set our account type by hand to admin. I'm going to save that. No, I'm not. I'm going to regret making this an enum account type because it does not look like pSQL likes to edit account types that are enums. Let me make it user. Does it want admin in quotes? That's interesting. Okay. Scratch that idea. We are just going to make it a sequelize.string. And we will force our database to update with the new structure again. And then once it reboots once, I'll take my force back out. I'm going to go back to my P-SQL. I'm going to refresh. I'm going to go to my users table, and we now have account type. That's just regular varchar string. I'm going to recreate my account. I'm going to come back to my database. I'm going to confirm that it was created. And now I'm going to set my account type by hand by saying account type is admin. Oh, you've got to be kidding me. P-SQL doesn't even want to let me edit it, even if it is an admin. Okay. Then in that case, we're going back to my original idea, and we'll just do it the good old-fashioned way of writing out some code. So we're going to force true one final time. We're going to put it back as an enum account type. No contents in the database, but my account type is sent back. I'm going to clear out my force. I'm going to create a new endpoint that says app.get super secret endpoint to make admin. And that's going to take some user ID. And there's going to be a async rec res that happens. And let's just close that out there. And what we are going to do is const userdb equals await models.user.find by pk. And we are going to use the rec.params.user_id that gets passed in. And we are going to userdb.account type is going to be equal to admin. And we are going to userdb.save. The other thing we are going to do is go up to our create account endpoint, and we are going to say, hey, when you create a new user, make their account type by default equal to a user. I just want to check the case and make sure the case of the enum matches the case that I typed in there. We are going to save. We're going to go back to our front end. We are going to hit create account. We're going to go back to our database. We're going to look at our content. We're going to refresh. And our password and zip code show up. And the account type got defaulted to a user. Okay, so what we could do in our add endpoint is query the database to pull out their account type and return the information based off of that. So let's start there. We are going to say, hey, if userdb.account type is equal to user, res.send the result as logged in as user. I changed my mind. It makes more sense to just return how they're logged in. Else, we are going to, if they're not a user, they must be an admin, but we could chain this with if else's here if we wanted to. We can say else res.send result user is logged in as admin and their zip code is and user db dot zip code. Okay, I'm going to take out this res.send at the very end before I forget about it because it's an if else. You can go back here. I'm going to log in with my username and my password and hit login. And when I click my am I logged in, I get am I logged in? I am logged in as a user. Okay, great. Now I can go run my super secret endpoint to make admin. And if I look in my P-SQL, my user ID is 1. So I'm going to make that person an admin by going to localhost 5000 and I'm going to run my super secret endpoint to make me an admin, and I'm going to pass in the user ID of 1. And it says localhost refused to connect. There are 2 problems here. One, I didn't res.send anything. So I should probably res.send a message, user is now an admin. And the other issue is I connected to localhost 500, not 5000. So if I connect to 5000, I now see user is now an admin. And if I go back to my React app and hit am I logged in, I now have user as an admin and their zip code is 12345. Okay, so remember that big spiel I went on of how you shouldn't store information in the cookie other than the user ID? Well, there's an exception to that. You should also probably store account type. Because what happens is, say we want to make some new endpoint that's only accessible to admins. Well, we can check to see if they're signed in pretty quickly with our login checker. But you know what we can't do is we can't see what kind of user they are without having to query the database, right? Which is what we're doing here. So what we are going to do is we are actually going to go back up to our login code. And we are not only going to set the cookie of user ID, we are going to set another cookie called account type. And that is going to come from the user DB of account type. And then if they're logged in as a user, instead of looking in user DB, we are going to look in rec.cookies.account type. And I am going to say, make the database query if they're not logged in as a user. Now we need this information, but we only need this information for their zip code, right? So if we wanted to, we could just take this out. And now we don't need the database query anymore. So let's just leave it as that for now. So I'm going to go back here. I do have to log out because I changed the cookie information. We need to run our login again. So I'm going to log out. I'm going to log back in. And I'm going to say, am I logged in? And user is logged in as an admin. OK, great. So I'm going to log out. I'm going to create another user account, which of course will be a user by default. I'm going to go back here. I'm going to hit login. User is signed in. Great. And when I run am I logged in again, I just have logged in as user. OK, that wasn't too bad. I thought that was going to be much worse. But I will wait for your questions before I make that statement. So one thing that I just want to note that I noticed here, when we run our endpoint, let's just take a quick snoop in here. What I am curious about is, can we see I wanted to see if we could see the cookie in here. Wonder if that's this E tag. Let's find out. I'm going to log out. And I'm going to log back in JLM, J3M, 3SM. And if am I logged in? We have our J3M, which does not match. Okay, never mind, ignore that. I never said any of that. Okay, so the one thing that I wanted to show here is we have our application tab, and we've been living a lot in console and network, and of course in elements as well when we were doing front end things. But in our application tab, we can actually go to cookies and go to localhost 3000 and see what information is in our cookies, which is kind of interesting. So we can see account type user and we can see user ID. So I'm going to stop sharing my screen for a second. I'm still around though, so if anyone has any questions, feel free to throw them out.
Can I share my screen with you guys and sort of like, I don't know, see where I'm at and where I need to fill in holes and even make sure that I have the right like support tools? Because it seems like you have a different like P-SQL app. Maybe I'm using like the wrong one.
Sure, yeah, go for it.
And do I use the live share or?
The share button is like the green one in the middle. I'm sorry, you should share from Zoom, not from.
Oh, not from Visual Studio Code. Okay, share. Oh, and there's all these like weird options.
And then is screen one of them?
Desktop one. Yeah.
That's screen one.
Okay. And then share. All right. Okay, so this is what I've got going on so far.
Okay.
I'm not even sure that like my file structure and stuff is proper either, but we'll see, I guess.
Yeah, the only thing that I see wrong is you shouldn't have a front end in a front end. So
I
when,
know.
when you run create React app, it's not like npm init, which is just going to dump the files in whatever folder you're in. When you run create React app, it creates a new folder for you. So you could run that right in your project folder as opposed to making a front end folder, CDing into it, and then running create React app on that.
Okay.
But that's a pretty easy fix. You can just go into Finder and drag out the second folder out back to where it should be.
Okay, cool. Should I do that like right now? Or is that like?
No, it's fine. It's not going to hurt anything.
Okay, great. So I guess you can't actually see any of that.
A little bit. Let's go to where do you think you're at, or where do you think you need help, or what do you have working?
I guess I don't even really have a good process for like, how do I check to make things are working? Like, I need to make sure the server is like on and stuff. I'm not sure that my front end page is like set up to actually render anything. Like the render section is completely empty.
Okay. So let's start with just getting your server up and running.
Okay.
So go ahead to your terminal tab. And you are going to CD to your backend.
Okay.
And then you can npm start. And so the backend server isn't starting. And if we scroll up a little bit, we see cannot find module MD5. And that just means MD5 is not installed.
Okay.
So would npm install that? So if you Control C, you can npm space install space dash dash save space MD5.
All right.
And then we can npm start again. And we get a crash again, and let's scroll up. And it's a different error, but we celebrate different errors. So that's decrypt. So go ahead and repeat that process with decrypt.
Okay. So we'll stop the server and we will npm install dash dash save decrypt. Okay.
Then go ahead and fire the server back up.
Oh.
So we won't go through all of this, but
Yeah.
you will eventually get all of them installed.
Yes.
What we'll do right now is just get the front end up and running. So go ahead and open up a new terminal by hitting that plus next to node. And then we are going to CD to our front end. And normally we wouldn't have to do this, but because your front end is in your front end, exactly, we're going to do that again. And now we can run npm start here. And your React is going to fire up a server, which is good. And then it is going to open up a new tab. And it's going to be cranky at you for that. So that issue is in your app.js file. So we will open that up. And basically what it's saying, so indentation is super important. So it's really hard for me to read this code. And if it's hard for me to read this code, it also means it's going to be hard for you to find when there are issues with the code or when things aren't lining up. So when you start adding things to the code, definitely focus on your indentation, right? So for this component did mount, let me just grab my screen drawing tools. And draw. So like this component did mount all right here should be on the same level as this on password change, right? Those functions are running in the same class. But it's kind of hard to tell if this closing bracket matches this closing bracket when the next opening bracket is all the way over here. So what I would do is before I even go into this code and figure out what brackets are missing or what's not lining up, I would adjust all the indentation to make sure I can kind of read it. And once you have your indentation right, it's going to be much faster to find out, oh, I have an extra curly brace that doesn't go anywhere.
Okay, for sure. Yeah, that was bothering me too. I guess I should have fixed it if it was bothering me.
And there are tools you can use. I have Prettier set up on mine. So every time I save the file, it automatically fixes the indentation for me. That has been a game changer for me in terms of how I write my code. Because as soon as I hit,
how do you use it?
I forget how I set it up in VS Code. It's not going to run this time though, because it won't run on code that doesn't have the brackets lining up.
Okay.
So once you have your code fixed, you can set up VS Code to run automatically every time you hit save. And that's a definitely a valuable tool. But there is also something to be said about trying to get it right when you're writing the code. And if something isn't indented right, and Prettier keeps on shoving it back to where you're like, no, 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 this should be indented, chances are that the code isn't in the right spot to begin with.
Okay.
So it's a great tool, but there's something to be said about having your indentation right the first time.
Mm-hmm. That makes good sense.
So what I would encourage you to do is on the backend side, just keep on hacking at it until you have all the modules installed. And then when you get errors that are cannot find module, that means that you're now onto, things in your code that aren't actually running. And then in your front end, I would continue to fix the indentation. And once you have that all fixed, it will be really easy to find out where you have the extra bracket or where something isn't lining up.
Okay. That sounds good. Awesome. Thanks.
Yeah, no problem.
Mm-hmm. That'll take me a while.
That's okay. You can end your screen share and I will take any other questions.
Okay, great. Thank you. Awesome.
Still staring at you, Jaquay. Can't hear you.
Anyone has capstone questions, feel free to ask them now. If anyone has conceptual questions or just wants to talk about the meaning of life, I'm also here. Any questions whatsoever, feel free to throw out in either Slack or in the Zoom room. I'm going to be here. I'm just turning off my camera.
but now they're okay. Suddenly see more.
Okay, last chance for any questions. And we'll end the stream in about 2 minutes if no one has any.
I'm good. I got to catch up. Rewatch last night.
Okay, I will be around all night. So as you're going through it, if you get stuck at any point, feel free to ping me in Slack and happy to jump on a quick screen share.
Okay, thank you so much.
No problem.
See you later.
Hey Max,
Yellow.
I made it. Did you answer any of the questions I posted in Slack? Like, should I rewatch the video or?
No, I thought
Can we
they
talk
were
about-
all, I thought they were all very dumb questions, so I refused to answer them. I'm just kidding. That's totally me being sarcastic. I did answer all the videos, all the questions you asked. I went over cookies. I went over storing addresses. I went over authorization and how to store that in a cookie. So you should be pretty good
Okay.
to go when you get back to the video.
Perfect, thanks. I have like only 4G, so like this is not working.
Gotcha. Yeah, it should all be
yeah.
recorded and visible in Slack in a couple minutes after the stream ends.
Okay. All right, thank you.
Yep. I'm going to go ahead and end the meeting. If anyone has any questions, feel free to send them over in Slack.